Okay, everybody, we're back in our notes, middle of chapter 4, vectors, and this is just picking up right after example 4.3, which I highly recommended that you watch, especially since I think it would be helpful for doing your homework for 2, I think, but those examples, yeah, that example will help you with that homework, but this is picking up right after that. All right, so this is, I actually meant to give you this video instead of the other one. There are 2 different methods of adding vectors together, and we're going to start not with the component method, we will do that later, but with what's called the graphical method. And that is, we're actually going to draw them out and add them together. All right, now remember, vectors are values that have a magnitude and they have a direction. All right, so when you think of adding vectors together, let's do red and blue right here. Let's say you have a vector that is 4 meters at, so this is a displacement vector, right? Displacement. 4 meters at east, okay? Or we could say at 0 degrees north of east, right? And then so you displace yourself from here to here, and you're now 4 meters more east. And then you displaced yourself again, another 2 meters. All right, so that's 2 meters at east, or you could say 0 degrees north of east. Right, and so we could say, all right, the resultant of that is not adding up. It's just like doing one big vector at 6 meters at east, or 0 degrees north of east. All right, that's pretty simple. All right, that makes sense. We're adding 4, and then we're putting 2 right after that, and it's like one big vector of 6. But it's just as true to add vectors together if they are not in a straight line, but if you put them, as we say, head to tail. All right, whereas the tail of one vector goes at the head of the previous vector. So it's just as true as if we were to say, all right, well, we're going to go, I'll go 2 meters first. 2 meters, 2 meters at east, sorry about that, all right, and then 4 meters right there, 4 meters at, we'll say, 90 degrees south of east, all right, south of east, or we could really just say at south. Okay, we're putting the tail of this vector at the tip of that one right here, and so you can see we've made basically we're about to make a right triangle. Even though they're at right angles, we still say we're adding them together as well, so that the resultant vector would be something like that. Well, whatever the square root of 2 squared plus 4 squared is, that would be this resultant vector r, or a, or b, or whatever you want to call it. So like we have up here, we could call this first vector a, all right, call the second one b, and call this resultant vector c right here. We can do the same thing here. We can call this a, we can call this b, and even though I kind of already called this r right here, meaning resultant, you could call that the vector c, that is the result of a and b adding together. So what I'm trying to show here is that things can be in a straight line. This vector plus that equals that. Okay, yes, that makes sense. But they can also be at angles to each other, at either a right angle or at some acute or obtuse angle. It doesn't matter. And you're still considering adding them together, because you're taking into account 2 things. You're taking into account each vector's magnitude, that is the length of the arrow, and you're going to be taking into account the actual direction that they're pointing. Now, I made this pretty easy for us because that's due east, that's due south, and so that would be a right angle right there. But in the next example, we're going to be adding vectors together that both have some sort of angle from the horizontal. And that's going to be what we're doing in this 4. Okay, so we're going to add together vector A and vector B, and get vector C. All right, now we're also going to need a protractor, and we're going to need a ruler as well. Now I'm going to sort of estimate this because I can't really put a ruler on my screen, and I don't have a protractor for my screen either. But you'll get the idea when you have these in front of you. All right. So when you add A plus B equals C. I should have drawn the different colors, but that's okay. Isn't it just as true to say B plus A equals C? Right? Doesn't matter what order you add them in. It's still just as true. So we can add these two vectors together in whatever order we want, and we will get the same resultant vector. I'll do it in the order that they're given to us, and then we'll do it in the opposite order, and we'll see that we get exactly the same thing. So, all right, let's draw this out. And this is what you're going to be doing in this graphical method right here of adding vectors. So I'm going to make vector A red, and I'm going to make vector B blue, and the resultant vector C is going to be green right here. All right, we're going to add them tip to tail. So let's draw vector A right here. It's 5 meters long. Now, obviously, I can't draw meters on this, so let's just cheat a little bit and we'll call this centimeters. All right. If you want to follow along on paper, it might help to make that centimeters right there. Centimeters, and that'll definitely fit on your paper. 5 centimeters at 60 degrees above the positive x-axis, or remember, above positive x-axis is like saying north of east, right? So let's go ahead and draw that. So 5 centimeters, I don't know what 5 centimeters looks like, but I'm going to do, and I'm messing up already. I'll make that a little bit steeper, I think. There's going to be 60 degrees. That's going to be the hardest part. So 60-degree angle from the horizontal is going to look kind of like this. All right? And we're going to say that's 5 centimeters long. So that's vector A right here. We're going to add to it vector B. Now, vector B, we're going to make it blue, of course, and we're going to make it 4 centimeters in length. So it'll be slightly shorter than vector A, but it's going to be 20 degrees above the positive x-axis, or it's going to be 20 degrees north of east, right? So the same general quadrant right here. But what I want to point out here is that we're going to use this point as a new origin. All right, so it's like we're going to pretend that we're going to, let me just change colors here for a second, make this a little gray right there. We're going to pretend that there's a new coordinate system starting right there for vector B. Vector B has its own coordinate system. We're not actually starting from the origin, but with regards to measuring our 20 degrees, we're going to pretend that there's a new x-axis right there. And this B vector is going to be 4 centimeters at 20 degrees from this new x-axis. I'll show you what I mean. So I'm going to make it a little bit shorter, and it's going to be 20 degrees off. All right, so this first one right here, that was 60 degrees above the x-axis. And this guy right here, this B is, squeeze that guy in there, that is 20 degrees north of east, or 20 degrees above the positive x-axis. Okay, we added them tip to tail, and we retained the same reference system just by starting kind of a new coordinate system right here and saying, all right, that's 20 degrees off that x-axis. So, all right, now we're just going to draw our resultant vector. All right, I should label that B right there. Okay, let's draw our resultant vector. This is the easy part. You start from your origin, and you go to the end of the final vector. Let's see how straight of a line, I messed it up a little bit. Well, it's about as close as I'm going to get it, I think. That's our resultant vector C. Okay, so what's the length of that? Well, I don't know, but you have a ruler. And if you've drawn this, you can measure this length out. That's why we call it the graphical method, because we're actually drawing it, and we're going to measure this length right here. Okay? It's, I don't know, it's 10 or something like that. All right, somewhere in that range. And we can measure our orientation or our direction of this vector C, because that is some angle above the positive x-axis. That is some angle north of east. All right, so C is going to be, I don't know, something centimeters at something degrees north of east. And what are those centimeters? That's for you to measure with your ruler. What is that angle right here? That's for you to measure with your protractor, because protractors measure angles. But that's what we call it the graphic method, because you're going to draw it out and you're going to measure the value of your resultant vector. Now remember I said you could do this in whatever order you wanted to? Let's say we started back here at the origin. Oops, I don't want to move everything around. Started back here at the origin and you drew your B vector first. What would that look like? Well, it would look kind of like that. B vector. 4 centimeters long and 20 degrees north of east, right? 20 degrees off the x-axis. And then if we started our new coordinate system right here at the tip of that B vector, we could add A to it, and you can see what's going to happen right here. Right there, there's our A vector. Our A, if we drew a new coordinate system, that would be 60 degrees off of that new coordinate system right there. So like that. So that'd be a 60-degree angle. So we'd get the same resultant. So whether you drew B first, didn't want to do that. B first and then A, or A first and then B, it really doesn't matter. As long as you have all of them tip to tail, you're going to get the same resultant vector no matter what order you add them in. Okay? So, this is what we're going to be doing on Monday. That's why you're going to need a ruler. That's why I'm going to give you a protractor, and that's what we're going to be practicing doing over and over and over again. That's basically going to be our lab. All right? Last little bit right here. We can add vectors. We can also subtract vectors too. All right? A plus B. All right, so here's here's A, right? Here's B, and this is C right here. Okay, A plus B equals C. But if we subtract B from A, we're going to get a different vector entirely. Now, what we have right here is, so D, vector D obviously is different from, I should label these right here, sorry. Vector D is obviously different from vector C. All right, so D is A minus B, or it's kind of like saying A plus negative B. All right, well, whatever our vector length B is right there, let's say it's 4 centimeters, something like that. Can you draw a length of negative 4 centimeters? No, I mean, the 4 centimeters is some scalar quantity. But where the vector comes in is with regards to the direction. So you can't actually draw an arrow that is negative 4 centimeters long, but you can draw a 4 centimeter long arrow in the opposite direction. That's what we're doing when we're subtracting vectors. So if we have vector A, all right, and then we subtract vector B, or we have basically negative vector B, we have the same length, but we have it in the opposite direction. So this vector right here, I won't make that green, I'll make it something different. Oops, got rid of it all. Try that again. B, so that's negative B right there. I'll make vector D be, I don't know, something orange or something like that. All right. That's a completely different vector from vector D, from vector C, I'm sorry. All right. So we just add the opposite, or we add the vector, but in the opposite direction when we subtract them. All right, so you still actually measure out a positive quantity, but you measure out a positive quantity in the opposite direction. That's what we do when we subtract vectors. So this is what I want you to come to class on Monday and ask me questions about this if you're not sure, because you're going to be doing this by hand several times over for your lab when you come in. So thanks for watching. Let me know if you have any questions, and I'll see you in lab. Take care.